Alright guys, welcome back. In this question, we need to replace the loading by a single resultant force and specify the location of the force measured from point O. So we have this loading that we can separate it in two different right triangles. Let's call this one, which has the base of 7.5, and we have the load that we know is 6 kilonewton per meter. And obviously, since we have a right triangle, the central and the center of gravity for this load will be somewhere in here, which we know will be 1/3 of 7.5 from the right side, or 2/3 of 7.5 on the left side. And for finding the force, we simply have basically the area of this triangle, which is 1 divided by 2 times 6 times 7.5, and this would give us 22.5. That would be a story for the left triangle, and we'll have the same thing for the right one. We know this time the center of gravity will be somewhere in here, which will be again 1/3 of, this time the base is 4.5, so this will be 4.5 meter. And same thing, we have 1 divided by 2 times 4.5 times 6, and this would give us 13.5. So we figure out the force of each of these two loads and where exactly it applies, and at the end of the question we need to find the resultant of all these forces. So other than these two load that we have a 15 kilonewton force that is applying on the other side of the beam, and let's call at the end we will have this resultant force of Fr, and we need to specify this distance d, which would be the location of the force Fr. So let's start with the sum of all forces in y direction, which would be our Fr, since there is no force in x direction, and we will have the force from left triangle, which was 22.5, and obviously negative, and we'll have 13.5 for the other one, and the 15 kilonewton force at the other end, and this would give us 51 kilonewton, and the direction would be downward. Now we found the magnitude of this force. We just need to figure out our distance and the location from point O, and if we go with the moment of all forces about point O, we call counterclockwise positive, and the moment of all of these forces are clockwise, and there would be, everything would be negative. So let's start with the left triangle, and with minus 22.5 force that we found. We're going to use the 2D shortcut that we have for finding the moment in 2D. There's a video in the channel for finding the moment about any point in 2D. I'm gonna put the link for the video in the description. You guys can check it out. So basically, I'm using that method for finding the moment. So we have this force times the distance, which would be the distance from point O, and that would be this distance that we have in here. I'm gonna show it in red. It will be this distance, since we have point O in here, and this would be, as I mentioned, 7.5, 2/3. And if you calculate that, we'll get 5 for this distance. The second force would be the force of the right triangle, which I'm gonna show it in green. So we'll have this distance, but before that, we know our point O is here, so we'll have 7.5 in here too. So we'll have 7.5 plus 1/3 of 4.5, and this will be 9. So now we have this. We have also the force of 50 kilonewton force at the end of the beam, and the distance will be 7.5 plus 4.5. And the last moment is the moment that we have at point O. We have a 500 kilonewton meter for the moment that is applying at point O, and that's pretty much what we have. And this would be basically our Fr times D. We already found Fr. We have minus 51 times D, and from here we can find D, 17.9. One mistake that I'm seeing in here a lot actually is that, so for this, the other side, I put a negative sign in here because I know that my FR is somewhere in here, and it's gonna make a moment of clockwise. So I'm just gonna put this negative sign regardless of what we have for F. And same here, we know the moment of that force will be negative. So we put a negative sign in here, and we put the magnitude of force 51. We don't need to put another minus 51 in here because that would mess up the answer. So we kind of go with the direction of the moment and we just put the positive magnitude of force, and obviously the distance is always positive. So putting this negative sign in here, it's already included the direction of the force, so we don't need to put a negative sign. And that would be the final answer for this question.